Okay, Mr. Hunt here, I'm reviewing the volumes review. Two types of questions here. First is cross-sectional volume. That's going to be number one. Then there's disk and washer questions moving forward about revolving. First, how do you tell the difference? Well, cross-sectional volume talks about base of a solid. It'll say something about perpendicular to an axis. Disk washer questions, and we'll go down here, revolving around. That's the key one. Right, you have a region, you're revolving, making a solid. Okay, so let's go back and do number one. One setup, but then different parts to it. So here's, it's not the unit circle, it's a circle with radius 2. That's the r squared value. So it's close to unit circle. That's a circle with radius 2. Set it at the origin still. Find the volume of the solid perpendicular to the given axis with the given shape. So A, we got x-axis. These are dx questions. You can even go ahead and fill these all out. Any x-axis is a dx, any y-axis is a dy, perpendicular to those axes. All right, so A is squares. Let me actually set it up, and then I'll make a little drawing. No pi in front here, that's disk washer. The interval, our x interval, is over this whole region. So we're going to need squares building up between -2 and 2. And then squares, the formula is s squared. And I already said it's a dx question. Here's a picture of what it's looking like. The square, it's supposed to be kind of 3D coming up from the page. Here's what I'll know that one, it's that. Okay, now I fill in things. -2 to 2, s. Well, s is here. It's that whole length. I will only know from the x-axis to the curve is y. Now, since the unit circle is symmetrical here, or well, a different circle with radius 2, this is also going to be the same as the top one. It will also be y. So my s value here is 2y. Sometimes it's half y. Sometimes it's just y. This one is 2y. And then what is y? Oh, well, we got to solve for it. I'll subtract x squared. So it's 4 minus x squared. And then y will be, do a square root. 4 minus x squared. And don't forget this squared. Calculator. 128 over 3 is a fraction, or 42.6 repeating. Going to dive into the next one pretty quick. Almost the same drawing here, dx still, but it's semicircles. So imagine that's a semicircle. Now for a semicircle, we want the radius. That's the formula. Here, let me write it down. Still -2 to 2. Semicircles, though, are pi over 2 r squared, and that's still a dx question. Okay, so now here's where I need the radius. Again, for these, you're pretty choosing between it's got to be x or y or half or 2 times them. Half x, half y. 2x, 2y. Last one was 2y. This one, I need the radius. The radius is just there. That's y. No 2, no half here. So y was this one up here. Square root of 4 minus x squared. I can calculate. I left mine in terms of pi, so I didn't put the pi in. I just left it out, and then when I put everything else in, I got 1600. So let's move on. Next one is these two are y-axis. See if I can draw a similar shape just here. First one is equilateral triangle. I'll give that formula to you if I ask for that on test or quiz. That's what it's looking like. This triangle is being built down there. Now it's a y interval. However, it still ends up being -2 to 2. But we're really choosing this -2 up to this 2. Okay, equilateral triangle. The formula is square root of 3 over 4 s squared, where s is the side of the equilateral triangle. And we mentioned it's already a dy question. Write these in. So I just need to figure out what s is, and then we'll be good. So side of the triangle that I'm going to get is going to be this base one, which is this. Now you should be thinking similar to the last one, like A, that is, the square all the way across. So did this one. We only know from the y-axis to the curve is x, but it's symmetrical on this side, and that's also x. So this one's going to be 2x. I bring the 2 down. X is, well, I have to solve for it. And guys, if we do the same solve as before, just different variables, it's going to be the same as this one up here. Just we interchange the variables. We subtract y squared, and then we do a square root. So it's instead of 4 minus x squared, it's 4 minus y squared. So it's square root 4 minus y squared. Calculator, okay, now if you look at my key, I left it once in terms of square root of 3, kind of like the pi one, where I didn't put in pi. I left the square root of 3 out, so you get a different answer. 32 thirds for everything else, and then a radical 3. Or just as a decimal, that's fine. Okay, and same one with semicircles. So it's just instead of trying a semicircle, similar as before, I only need x this time. I don't need the entire diameter. I just need x. Still negative 2 to 2 from over here. Semicircle pi over 2 r squared dy. And then as I just said, that r is x here. And x we just wrote in as 4 square root of 4 minus y squared. Don't forget that squared. Calculator 16 thirds pi. You'll notice it is the same as b. That doesn't usually happen, but because these were symmetrical, top, bottom, and it's just unit circle, but radius of 2. So circle of 2, radius 2, that's why they end up being the same. Okay, that's cross-sectional volume. Let me do the rest, which are disk washer. So number 2, find the volume of the solid by rotating around or bar. This implies disk washer. If I graph these functions, 4 minus x squared, up 4, but it's the parabola opening down. 3 minus x is up 3, but then the diagonal line going down like that. So here's the region. And we're revolving around the x-axis. Those are it's the easier ones. Here's the x-axis. First thing is disk washer. Well, there's this big gap here, so it's washer. So then I need some pi, interval. Now, here's what I had to do on this one. I should have mentioned this up here. I need to find these intersections. And when you set these equal, now we normally set them equal to find the intersection and solve. It can't be factored in quadratic formula. Quadratic formula would work, but it's going to get you decimal values. So I used a calculator and found they intersected here at an x value of 1.618, and they intersected here at an x value of negative 0.618. So then it's r squared minus little r squared, and x-axis is a dx question. Again, you could fill out all these. I mean, I can go through on the next ones. Any horizontal line is a dx question. Any vertical line is a dy question. That's horizontal. Vertical, dy, vertical. Let's finish this one off, though. Okay, same, I'm just going to rewrite these. 1.618. I need capital R. From my axis here, up to the outer part of my curve. Well, remember, x-axis, you can look at my chart here. I have it on the board. I'll make a quick chart just in case you can't. You're not in class seeing this. If you're revolving around the following axis, x or y, your r or little r value will just be x or y. If you're on the left of your region or below the region, it's gonna be like this: x or y, one of those, plus a number. Or you can start the number first, number plus x, y. If you're on the right of the region or above, it's gonna be kind of reversed: number minus x or y. That's the little chart I'll be referencing here. So on this one, it's x-axis. So we're just going to be x or y. And since it's a dx question, it's going to be y, so then the variables will be in terms of x. So what I just outlined up here, from here to here, is y. Now, it's y for the top function. The top function was the 4 minus x squared. So that's what goes in here. Don't forget the squared. Then little r is little r is actually the same, it's just y, but it's to the inner region. It's another y, but it's a different y. This time it's the 3 minus x. That's the graph, the line. Okay, again, put your calculator. I left the pi out, so I got approximately, it's a little rounded because of these, but about 11.18 pi. Okay, let's do the back side. 6 different problems, but they're all based on one graph. Very important to get the graph right. If you don't get that right, I mean, you're going to have troubles. Find the volume of the solid of revolution, revolving around. Revolving around the region bounded by these. X cubed. Now, I'm not going to draw much down here, but it goes like this. We're only in quadrant 1. So it goes like that, roughly. Too steep, maybe. X equals 0 is the y-axis. And y equals 8 is the horizontal line at 8. So here's our region. Certainly a y-interval, 0 to 8. Okay. And then I need to know what this would be for an x-interval, 0 to something. Well, it's where 8 and 8 equals, these y's are equal. Y equals 8 and y equals x cubed are equal. So I'm going to set those functions equal. Cube root will give me x equals 2. So you can actually set most of these up a little bit. You don't know disk wash or fall, but like this one, it's a dx question. That's an x interval, 0 to 2. Over here, a y interval, pi, 0 to 8. It's a dy question. All right, so we got our region. Let's jump in. X-axis, right here. There's a gap. It touches there on the left, but there's a gap. So it's a washer. So I got capital R squared minus little r squared. I've already said it's a dx. Okay, so capital R, referencing the chart, if it's an x-axis, it's just going to be a y, or x, so in this case y. R outer is to there. I try another one, they're all the same, they're all 8. So it's a y value, but it's the y value for the function 8. Minus, okay, little r is going to be from our axis up to the curve there. And again, it's changing. So I went here, go down here. So it's a y value from the x-axis to the curve, same as before, but it's the other y. It's that one, x cubed. Okay, make sure to write the squared there. As a fraction, 768 over 7 pi. You can leave the pi out. Next one is a y-axis question. It's dy. Now run the y-axis. Okay, well, for the region, no gap. So I'm just going to put d, disk. So all I need here is r squared. So I just need to figure out what capital R is. Again, x or y-axis, just x or y. And this time, since it's the y-axis, vertical line, from my axis over to the curve is x. And that's going to be what R is. Now, I haven't done yet what x is. the function that it's based on is y equals x cubed. That's solved for y. I need to solve for x. So I can just do a cube root. And I'll get x is cube root of y. Okay. Put in your calculator, 96/5 pi. Also, I put the decimal values as well, 19.2 pi, if you wanted to use that. I'm going to keep going, finish up the last four here. These will not be around the x or y axis. Next one is y equals 8. Okay, well, that's this one. Let's get rid of a few of these. Y equals 8 is right here. No gap. So it's a disk. I could have done this before as well. It's a dx question, and so it's an x interval. So it's 0 to 2. It's that one, 0 to 2. Disk just r squared. So I just need to figure out what capital R is. There's only one radius here. From my axis to the region, just the outer part of the region, it's changing if I went here or here. Now, if you look at my chart from before, if you are above, which we are above the region, just above it, then it's going to be a number minus x or y for your radius. So on this one, I don't know the green line right now, but I do know from the x-axis to that curve is y. And I also know that this whole thing is 8. So using segment addition and then subtracting, it'll be 8, take away y to get a green segment, which is the radius. 8 minus y. And y we already had, it was x cubed. Calculator, 576 over 7 pi. 576 over 7. Next up, let's see, negative 2. Let's just move that down there. Negative 1, negative 2, about there. It's a we already did dx. All right, let me start to fill it in here. Pi. It's 0 to 2 in the interval because we're still a dx question. Okay, washer this time. There's all this gap. So it's a washer, so I need r squared minus a little r squared. And we said dx. Pi 0 to 2. Okay, let's get my capital R. From here to the outer part of the region, not changing. It was 2 to here, and then 8 more up. So it's 10. Capital R is just 10. Now I need little r, which is here to there, the inner part of the region. It is changing. This part is not, though, in blue. That is 2. Then the green part is y, x-axis to the curve. And here I mentioned it again. If you're below, I'll go back to this table here. If you're below, it's going to be an x of y plus a number. So in this case, we've got 2 plus y, or in other words, y plus 2. Oh, here. Here, I like to do this. The r, that times y plus 2. So then I fill it in down here. Y is x cubed. You could do that in multiple steps. I just like to do it all in one. Calculator, 1104 over 7 pi. That's a 0. 1104 over 7 pi. Okay. Last two. Both dy questions. First one is negative 2. If we are on the left of the region, I'm just going to refer to my chart. It's similar to the last one. It's a plus. Now, we'll say that here's negative 2. It's a dy question. Let me go ahead and set it up. So we need the y interval, 0 to 8. Let's see, disk or washer. Wow, there's all this gap here. So it's going to be a washer. R squared minus little r squared, and then dy. Okay. Let's Now r squared, from our axis, from our axis to the outer part of the region, it's different lengths there, so it has a variable involved. For referring to the table, it was a number plus x or y. In this case, 2 to get to the y-axis to the curve, x. So it's going to be 2 plus x. Then I put in what x is, because overall I want it in terms of y, and x is cube root of y. We've done that earlier. Finally, little r is here to here, to the inner part of the region, just 2. It's constant. Okay, dy, yeah. And calculator, 336 fifths. Y. Last one, dy question. So we got the 0 to 8. Dy over here. What was it? It was y, no, x equals 4. X equals, there's 2, so here, let's say the green line is about 4. Certainly a wash or a lot of gap in there. So now r squared minus little r squared. Okay, I need capital R. Green line is on the right, referring to the table, number minus x or y. So, for one of them, it's actually going to be the second one. Here to here is capital R, axis to the outer part of the region, not changing. Not changing, it's 4. Little r will change though. Little r is from our axis to the inner part of the region, which you can see is different lengths there. This, again, I mentioned it's going to be a subtraction one. I know that from the y-axis to the curve is x, and I know this whole thing is 4. I can then find that this color, whatever it is, that segment is 4, subtract x. Calculator, 384 fifths.